Okay, so now the fractions are gone. Now I can collect like terms. If I add 1 to both sides, I'm going to have 10x minus 6 is equal to 10. If I add 6 to both sides, 10x is equal to 16. So x is equal to 16 tenths, and I want to reduce that. 2 goes into 16 8 times, and 2 goes into 10 5 times. So x is 8 fifths. To find y, I'm going to substitute that either into the first equation or the second. Okay, whatever's easier. I think the first equation would be a little bit better, and which is here. So I'm going to use y is equal to 3 times 8 fifths minus 2. That's 24 fifths minus 2. 3 times 8 is 24 over the common denominator. Put that over 1 if you need to. Okay, and now I've got to combine these again. So I can multiply 2 over 1 by 5 over 5 to get the denominators to be the same. That's 24 over 5 minus 10 over 5, right? 2 times 5 is 10, 1 times 5 is 5. The denominators are the same, and so now that means that I can go ahead and add or subtract the numerators and put the same denominator, one denominator, right? 5. 24 minus 10 is 14, and I can't reduce that anymore. So the x-coordinate of the point at the foot of the perpendicular is 8 fifths, and the y-coordinate is 14 fifths. And now I can use this point in conjunction with point P, which was given to me at 1, 3, into the distance formula. So let's do that. So we have distance, and I'll write the points up here again so you can see them. 8 fifths, 14 fifths, and 1, 3. So they're not pretty numbers, but again, that's what we got to deal with. So remember, it's x1 minus x2 squared, so 1 minus 8 fifths squared, plus y2 minus y1 squared. I've got to clean up these fractions in here. This is 5 minus 8, or negative 3 fifths squared. Over here it's 15 minus 14, or 1 fifth squared. Negative 3 squared is 9, 5 squared is 25, 1 squared is 1, 5 squared is 25. That gives me same denominator, 25. 9 plus 1 is 10. I can write these in their own radicals, root 10 over root 25. Root 10 is going to stay root 10, because if I factor that out, the only factors are 1 times 10 or 2 times 5, and there's no perfect square in any of those factors. However, we know that the square root of 25 is 5. So the distance between the 2 points, between this point here, which is 1, 3, and the foot of this perpendicular, which is 8 fifths, 14 fifths, is, what I say it was, 10 square root of 10 over 5. Now if I put that into my calculator, I have the calculator there. If I do the square root of 10, divided by divided by 5, it's about 0.632. So this is a very tiny number, a very tiny distance, and you could even say that that's approximately equal to 0.632. Okay? Very tiny. That's how you find the distance between a line and a point not on the line. And you have practice on the worksheet I gave you today, like the first 4 problems, I think, are just finding the distance between them. Okay? The next video, I'm going to cover distance between parallel lines. Okay, so I'll post that as soon as it's done.